Okay, before we start today's lesson, I want you to think about a positive and write it down on the top of your notes. My positive, not necessarily a positive, more of a funny, which might not apply to the next group that ever watches this, is that we had the sun and we had snow and we had sun again today. Welcome to Chicago. Okay, so I hope you got something positive. And today's lesson actually is just going to be review of stuff we've done, but it's important to go back over this material for when we solve quadratics in a couple days. And this is actually, the solving quadratics with imaginary numbers is actually a really big concept of Algebra 2. Okay, but today, like I said, is just going to be review material. So if you recall, this is a radical symbol. And then this number right here is the index. Remember that this is not a coefficient. Okay, and typically if it is 2, we don't see it there. And then the radicand is what's underneath the radical. Okay, so we have to pay, when we're simplifying radicals, we have to pay attention to what the index is, if you recall. So in this example, the index is going to be a 2 here. Okay, and then we have to break this down. 63 is not a perfect square, so we want to see a perfect square that goes into it. So that would be 9 and 7, and then 3 and 3. So whatever you make a group of, that's what goes on the outside, and then whatever you have left over is what goes on the inside. And then when you have the square root, you're looking just for powers of 2. So this is a power by itself, so it can be taken out. So the negative stays on the outside, and this is going to be negative 3x, and then square root of 7. Okay. In the next example, once again, that is a square root up here. So 90 is not a perfect square, so this is 9 and 10, 3 and 3. Okay, 10 can get broken down into 5 and 2, but notice that that is not a perfect square at all. We can't make a group of 2. So this is what goes underneath. You box the leftovers and you circle what comes out. Remember that whatever does come out, you need to multiply it by the number in front. So now we have 6x. Okay, and at the moment, we have a leftover of 10. And then x can be broken up to x squared times x. So I can take out an x squared and I'm left with an x underneath, because here's one group, here's two groups. The y's, I can take one group out. And then for the z's, that's going to be z to the second times z to the second. So I can take two groups out. And that leaves me z to the second. So my final answer would be 6x to the third, y z to the second, square root of 10x. Okay, in the next example, just be careful because this is the fourth root. So now you're looking for groups of 4. So if you break this up, let's say you did 8 and 6, 4 and 2, 2 and 2, 2 and 3. I'm looking once again for groups of 4, and then I box my leftovers. So this is 2, fourth root of 3. Okay, and then briefly on the last one, remember that if it's an odd root, the negative is okay, just take it out. Okay. If it is an even root, you can't have a negative underneath, which is what we're going to learn about actually tomorrow on what to do in that scenario. Okay. All right, so adding and subtracting radicals. Remember that we treat this as combining like terms. So if they have the same radical, meaning the same index, the same radicand, then we can add them together. The numbers in front. If not, then we can't. So if we were thinking about combining like terms, we could add these two together. But this scenario, we couldn't because of the fact that it's squared. Okay, let's take a look at number 1. Notice that it has the same radical, so we just combine the numbers in front. So this is going to be 8 root 2, and you're done. Okay. In the next example, you want to make sure that you simplify before you make a conclusion if you have any radicals that are the same. So we need to break this down. 7 and 4, 2 and 2. So I can take a 2 out, and I'm left with root 7. Minus 3 root 7. And then 40 is going to be 8 and 5, 2 and 4, 2 and 2. So I can take 2 out, and I'm left with 10 underneath. Remember that you multiply those together. So this is plus 2 root 10. Okay. Then you only combined the ones that are the same, which in this example would be the root 7s. So my final answer is negative root 7 plus 2 root 10. Remember that you do not add the insides together. You do not add the insides together. You just combine the like terms. Okay. All right, we're going to skip the next example. Let's see if I can erase that. Nope. So that little box is going to stay with us now as we go along. So multiplying radicals, you can either multiply them together to start, or you can simplify them to start. It doesn't matter. Okay. So let's say we simplified them first. This is going to simplify to 2 root 2. This will simplify to 2 root 6 because 4 is the perfect power that goes into both. And then when you multiply, remember that you multiply outside times outside and then inside times inside. So this is 4 root 12. Okay, and then when you're done, make sure that you can't simplify this any further, which you actually can. This is 4 and 3, 2 and 2. So I can take a 2 out, make sure you multiply it by the number in front. So this gives me 8 root 3 as my final answer. Okay. All right, let's take a look at number 2. Okay. For number 2, we're going to want to expand this. So 3 root 5 times 3 root 5. So multiply outsides together, that's 9. Multiply insides together, that's 25. So 9 times 5 is 45. All right, and then let's go to the next page for the last example that we're going to do for multiplying. So we need to FOIL this. So this is going to be 8 plus 20 root 3. So multiply outside times outside, inside times inside. Do not mix. Minus 2 root 6 minus 5 root 18. Once again, do not mix. So this is 6 and 3. That's where you get the 18. 5 on the outside, negative 1 on the outside, and that's how you get negative 5. At the end, see if you can simplify any further, which we can take 18 and do 9 and 2, 3 and 3. So 8 plus 20 root 3 minus 2 root 6 minus 15 root 2. I cannot combine them. There's nothing that's the same, so that's my final answer. Okay. All right. And then remember with dividing and rationalizing radicals, so you can never leave a fraction underneath the radical. So like number 1, we can't leave it like that. And you can never leave a fraction in the denominator, like number 2. So in the situation of number 1, where you do have a fraction on the inside, you can actually split this. So take the square root in the numerator, take the square root of the denominator, and in our case, we're lucky because these are both perfect squares, and we're done. Okay. Notice in number 2, though, it's already split for us, but we have a radical in the denominator. So root 72 over 2. You cannot divide those. Please, 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 please do not make that root 36. Okay, the 72 is trapped underneath the radical. Okay, so what we do have to see is if 72 can get broken down, which it can. 36 and 2, 6 and 6. I can make a perfect pair of 6s. So 6 root 2 over 2. And then since both of these numbers are on the outside with no plus or minus sign, I can cancel these and make this 3 root 2. Do not cancel from underneath the radical. Okay. In example 3, we do not have perfect square underneath, so remember we have to do what's called rationalizing. And rationalizing is where you multiply by whatever underneath the radical if there's no addition or subtraction in the denominator. So this is going to be root 2 over root 4. Now remember that the whole point of rationalizing is to get rid of the radical in the denominator. And so what we did was we made a perfect square underneath. So this is root 2 over 2. Once again, do not cancel these. Okay? 2 and 2. Yes, that's good. Root 2 and 2, not the same thing. Okay? All right, let's jump to, we'll do one more and then we'll move on. So root 8, some of you might recognize that that actually can simplify right away. If you don't, that's fine. Just multiply by root 8 over root 8. So 5 root 8 over root 64. Now, hopefully you do notice that if you didn't simplify this first, this is 4 and 2, 2 and 2. So I can actually simplify that, box my leftovers. So that's 10 root 2 over 8. Okay. These numbers are on the outside of the radical with no plus or minus sign, so we can simplify these to 5 root 2 over 4. You do not have to worry about the heart in this case because there is no addition or subtraction. That's when you do have to worry about the heart. Okay. All right. Now, the last part, until we talk about rational exponents again, is to use conjugates to rationalize. So remember that conjugates are basically just pairs of radical expressions that are where the radical sign is opposite of each other. So notice this is addition, this is subtraction. Okay, so the conjugate of a plus root b is going to be a minus root b. And the reason why we want to multiply by the conjugate is because when we multiply these two together, if this is in the denominator, actually it doesn't matter if it's in the denominator, but we would do this in the situation that it is in the denominator, these will actually all cancel out to be a squared minus root b squared. So a squared minus b. If that's super like whoa to you, just FOIL it out and you're going to see that radicals cancel. Okay? And I'll do one example like that on the next page where we do FOIL it out so you can see where that came from. All right, last page. So we can't multiply by just root 5 in this example due to the fact that there's addition or subtraction in the denominator. So what we have to do in that situation is multiply by the conjugate. So remember that's going to be the opposite sign, so 3 minus root 5 over 3 minus root 5. Okay, and then the top I'm going to multiply out, so I'm going to distribute the 1 to everything, which when you multiply by 1 it's just going to keep it the same. And then in the denominator, like I said, if you're not sure about what we just did, then FOIL it out. So 9 minus 3 root 5 plus 3 root 5 minus root 25. So these cancel out, which they should, and then this is just going to be minus 5. So notice that all the radicals go away. If you just would have multiplied by the radical, that wouldn't have happened. So you made a mistake somewhere. So 3 minus root 5 over 9 minus 5, which is 4. See if you can complete the heart, which you can't. So you're done with the problem. Okay. All right, let's do one more of those. So we have addition in the denominator, so I need to multiply by the conjugate. So I'm going to multiply by 2 plus root 7. Okay. So on the top, I need to distribute this through to everything. Remember, multiply outside times outside, inside times inside. So 6 root 2 plus 3 root 14. Okay. And then in the bottom, FOIL it out. So 4 plus 2 root 7 minus 2 root 7 minus root 49. So these are going to cancel, which is what we want. And then this is going to be minus 7. So I get 6 root 2 plus 3 root 14 all over 4 minus 7, which is negative 3. See if you can complete the heart, which in this example you actually can. You can take a 3 out of that side. You can take a 3 out of this side. So that's negative 2 root 2 minus root 14. So the negative will get distributed through since the 3 goes in perfectly. Make sure that you don't just cancel 1/2 the heart. It has to be a full heart because we love math. Okay. All right. Last thing we're going to talk about in this video is switching from exponential form to radical form, which we've done before. Remember that the roots of the tree are on the bottom. So this would be the roots, or in other words, the index. And then this is the power. So once again, here's the power and here's the index. So they are equivalent of each other and you can flip back and forth in between them. And that's actually the first part of this is what we're going to do is we're just going to practice flipping between the two. Okay, so if we look at the first example, this is the power on the outside. This is the index. So just write it power over index. So 7 to the 2/3, and you're done. Okay. And then the second example, once again, this is the power. This is the index, which is a 2. Since we don't see a number there, it's implied that it's 2. So 3 to the 5/2. Now, if I would have written this, the square root of 3 to the 5th, that would be the same thing. That would still be 3 to the 5/2. Doesn't matter. It can be on the outside or on the inside. Okay, and then in the last example, so this is 5x squared in parentheses, since there's more than just a variable or a number. Power over the index. That simplifies to 5x to the second. And since this problem is nice, meaning that we don't have a fractional exponent left over, this is just 25x to the 4th. Okay. And now the next part, we're going to work in the opposite direction. So we're going to do converting from the exponential form to radical form. So this is the power. This is the index. So square root of 16, which we can simplify that to be 4. Okay. Once again, this is the power. This is the index. Now, because 11x is in parentheses, all of this is going to be taken to the 3rd power. So 4th root 11x to the 3rd, or you could write it like this, where the power's on the outside. It means the same thing. Okay. And then the last example is just number 2 again, but just different numbers. Okay. All right, one last thing to go, just evaluating. So what we want to do is write numbers in a lower space possible. And if you're not sure what the number is going to be, always look at the base, because a lot of times, the base of the exponent, a lot of times that will be a way you can rewrite 9 to that power. So for example, the base is 2. Can I rewrite 9 as a base to some power of 2? Which I can. That's 3 to the 2nd to the 1/2. Then when you take a power to a power, you multiply the exponents, and I just did the hand movement even though you can't see me. So you multiply the exponents. That's just going to be 2 times 1/2, which is 1. So this equals 3. Okay. All right, example 2, same thing. Yes, I know 16 is the same thing as 4 to the second, but if you do that, you're going to have more work to do. But look at the base of the fractional exponent. Can I rewrite 16 as a power of 4? Which I can. 2 to the 4th to the 1/4. So power to a power, you multiply the exponents. That's going to be 2 to the 1st, which is just 2. Okay. All right, 2 more to go. So you could either do this one as 4 to the second or 2 to the 4th. It doesn't matter. I'm just going to do 2 to the 4th since we just did it that way. So now when you multiply 4 times 3 over 2, that's 12 over 2, which is 6. So this is 2 to the 6th, which equals 64. So when you take power to power, you multiply the exponents. That's what I just did. Alrighty, last example. So this is 3 to the 3rd. It's a perfect cube. Multiply the exponents. So 3 times 2 over 3, that's going to be 2. 3 to the 2nd equals 9. Bingo, we are done. Okay, hope you all having a wonderful day. And thanks for watching.